Okay, so this is just a little bit of a supplemental video that we wanted to provide to talk about radio transmission and the topics that were covered in the previous video. If you did not watch the video called How Do Radios Work, you should watch that video first because it really covers a lot of the basics. But in reality, what we wanted you to see here is that this concept of radio is really just a smaller part of a much, much bigger idea. If you remember, moving charges create magnetic fields. That's the first rule of magnetism. In the video, How Do Radios Work, there was a couple different little illustrations they were doing where they were taking this coin and they were sparking it against the battery. Well, when they're doing that, the battery basically is providing a potential difference across the copper coin. And that is basically like just momentarily making the charges pulse or move. And when those charges move, according to the first rule of magnetism, they create a magnetic field. And that's really what they were showing with these little dots moving through space. In a different spot in the video, they had this illustration, and basically what they were showing is that when you turn this switch on and off, you were making this compass needle or this magnetic field move back and forth, and that magnetic field moving through space is what ended up reaching the receiver. When you make charges oscillate, that means that the charges will move, back and forth along a wire at a very regular rate. They send out magnetic fields that also oscillate, and those magnetic fields will oscillate at the same frequency that the charges themselves were oscillating. So if your charges are moving back and forth 10 times per second, it'll send out a magnetic field that changes 10 times per second. These oscillating magnetic fields, these are called electromagnetic waves. Okay. Now you've probably heard about electromagnetic waves before because that's really what we call light. In this graphic that I have right here, I know you can't see it very well under my webcam, but this really just shows you the full range of the electromagnetic spectrum. These are all just oscillating magnetic fields, right? And these oscillating magnetic fields are only different by what the frequency of that oscillation is. If you have a really low rate of oscillation, something that doesn't oscillate very quickly, it fits down here on this end of the electromagnetic spectrum. And really all of these are low oscillating magnetic waves. Now, when I say low, I still mean they're oscillating at the order of up to maybe 300 gigahertz, which is, 300 times 10 to the ninth hertz, which is quite fast, right? I mean, those are oscillating magnetic fields that go crazy fast, but they're not near as fast as the magnetic fields that are way up here, which are like, well, I can't even tell what that is, but it's a lot of hertz, right? I mean, the visible spectrum of light, which is right here in the middle, okay, that visible spectrum, those magnetic fields oscillate in the order of 10 to the 14th times per second. So, I mean, you're talking about crazy fast oscillations. So really, whenever you have a magnetic field that is just changing back and forth, back and forth, back and forth, and it travels through space, we classify it as an electromagnetic wave. And I have a note here, these electromagnetic fields can travel very fast. I mean, they travel at the speed of light because that's what light is, right? 2.998 times 10 to the 8th meters per second. Well, when you were looking at that video about radio, really what they were talking about was the idea that those oscillating magnetic fields can really just be sent out from a transmitter through space, and they can be picked up by a receiver, and then that receiver can encode or decode that message, whatever message was encoded on top of it, and pump it out onto a speaker. I mean, really, this little illustration right here, if you think about it, really shows you all of the rules of magnetism just happening, over and over and over again. You have a person here who's creating a sound, right? Those sound waves are mechanical waves that are happening because of oscillations in the air, right? And those air molecules hit this microphone. Well, the microphone takes advantage of the second law of magnetism. It makes the voice coil bounce back and forth, which creates an electric signal. And then that electric signal basically travels through a wire and gets amplified until it goes to this antenna. And then that antenna really just has those electrical signals oscillating back and forth the same way, creating an oscillating magnetic field that moves through space, right? That's the first rule of magnetism right here. Moving charges create magnetic fields. And then those moving magnetic fields travel through space. Those magnetic fields hit some charges. That makes the charges move. So now you're back to the second rule of magnetism again. You go through some amplification and decoding process again, and then it pumps out to a speaker, which is moving charges create magnetic fields, and that then therefore makes the speaker move back and forth and create sound. So, I mean, in reality, this entire transmission system that we show you is really just an example of all of the rules of magnetism being used one step after another. So, I don't know, hopefully you can see like just how valuable the laws of magnetism are in nature. I mean, really, most of everyday technology that we depend on really depends a lot on these rules of magnetism. So it's too bad that we aren't able to like be in the classroom and be able to demonstrate some stuff live for you guys, because there's some really neat stuff that we could show you. But I'm sure you can do a lot of more research on this if you'd like, and see some better examples. All right, so that's it for today's lesson. As always, you can reach out to your teacher, or come to some office hours and ask any questions that you might have. Thanks, guys.